Let's talk about the conductivity of specific compounds, in particular ionic compounds. The conductivity is just the capacity for a material to conduct electricity. And probably you already know this because you may want to know what kind of material you can put in an electrical outlet. You know that if you use plastic, you're fine. If you use a metal, probably you're not. The same way that if when you're taking a bath, you don't want to be holding anything that is electrical, because I think you may know that water and the ions in it conduct electricity. Let's try to understand what you already know in terms of ions in solution, or what kind of element is actually conducting the electricity. The take-home message is that a material will be a conductor, will conduct electricity when there are charges that can move. And that's what we are looking for. Any material that has charges that can move, that being electrons, such as metals. Metals conduct electricity because, as you remember, the metallic bond is a pool of electrons, so the electrons are free or almost free to move back and forth. Alright, so the solid ionic compound, notice that positive and negative are trapped in that lattice. A solid ionic compound does not conduct electricity. However, when you melt this solid ionic compound with a lot of energy, right, you have to really melt, you have to provide a lot of temperature to melt the solid compound. Now you have free charges. Now, as you well know from the state of liquid, what it looks like, the arrangement compared to the solid, the arrangement of the particles in liquid is not as organized. Therefore, the cation and the anion can move back and forth. Therefore, molten ionic compounds can conduct electricity. And without having to increase the temperature that much, if you throw the solid ionic compound in water, what we said we had is free charges surrounded by water. So therefore, now you know why it's no good to hold a toaster while taking a bath. It's because you can die of electrocution, right? Because the water with which you're taking your bath probably contains some salts, and that actually conducts electricity because you have free charges moving that can move in the solution. Therefore, they can conduct electricity. So what we want to emphasize is that it depends on the conductivity depends on the kind of material, but also on the phase of that material, depending if it's solid or if it's liquid, etc. So notice that the ionic compounds will conduct electricity not as solid, but when they are liquid or dissolved. The metal compounds will always conduct electricity, and I should say when it's liquid or solid. I mean, gas, it's a little bit more complicated. And the covalent compounds, typically, we will say no. When you have molecular solids or molecular liquids, those will not conduct electricity. However, there are some compounds, and I'm thinking of graphite. Graphite is just planes of sp2 carbons which have some resonance. They have some free electrons that they can conduct electricity. Alright, but that would be an exception rather than the norm. Typically, covalent compounds, molecular solids, will not conduct electricity regardless of their phase. Alright, so in this case, it's asking to decide if the following compounds at that specific state will conduct electricity or not. So let's see. This is ionic, it's an ionic solid, and therefore it does not conduct electricity. However, magnesium chloride, and there's a 2 missing here, it's ionic, but it's liquid. If it's liquid, it means there's free ions moving, so yes, it conducts electricity. Phosphorus fluoride, it's molecular, and we said up there that molecular, regardless of the phase, it does not conduct electricity, so it's a no. Lithium chloride, and in this case is AQ. What does that mean? It means aqueous, it's in solution, so it's ionic, in solution. Remember the toaster, do not hold the toaster while taking a bath. It means that because it can, ionic compounds in solution can conduct electricity. Sodium, it's a metal, and metals, regardless of if they're solid or liquid, they do conduct electricity. And finally, carbon dioxide, it's gas, so it's even less likely, but it's a molecular compound, therefore they will not conduct electricity. Hopefully that makes some sense.